Today we're going to code with an abacus. We have our hardware here in front of us, this nice computer that my children were kind enough to let me borrow for the day. And we have our software, our algorithm here that we're going to use to try to come up with a decimal representation for the square root of 2. The way this method works is that we are changing this into an equation that we are trying to find a solution for. So if x is equal to the square root of 2, that means that x squared is equal to 2. And so we're going to follow a simple 3-step process. We're always going to have a low value for x and a high value for x, meaning a number that we know is less than x and a number that we know is higher than x. So the first step in the algorithm is to calculate the midpoint. That's going to be the low point plus the high point divided by 2. Then we're going to take that midpoint and square it because we want to check for whether we are above or below 2. So we're looking, are we less than 2? Are we greater than 2? Because based on that, we can then update our value of low or high, and then we repeat until we've got close enough to within the precision of our machine here. So our low value and our high value are going to start out at 1 and 2. All right, I know 1 is too low because 1 squared gives me 1, which is less than 2, so this value must be too low. I know that 2 is too high, for 1, because square root of 2 is implicitly less than 2, since 2 is greater than 1. But also because 2 squared is 4, 4 is obviously greater than 2. And so we'll start with a low value of 1 and a high value of 2. So let's move on to our first step in the algorithm, which is to calculate the midpoint. Our midpoint is low plus high divided by 2. So I'm going to take 1 and 2 and add them together. So I'm going to come up to my hardware here. I've got 1 up here. And just to keep myself honest, I'm going to put a 2 down here. So I need to take these two numbers and add them together. So I'm going to take 1 off from here, add 1 onto here. Then I'm going to take 1 off from here, add 1 onto here. I have no more values down here in the thing I was adding, so I've taken 1 plus 2 and gotten 1, 2, 3. Then I need to take that, divide it in half. So we are going to take this thing and divide it into 2. So I'm going to record this number down here in my memory here. And now what we're going to do is simply record what happens to this number when we divide it by 2. So the way we divide by 2 on an abacus is I just take 2 beads at a time and slide them over this way. For every 2 beads that I sort of clear from the memory here, I'm going to add 1 bead over here. So I take away 2 from here, add 1 to the number up here to my output. So down here is my input, up here is my output. I come down here, I do not have any more beads to give. I only have 1, and I can't really split the bead in half. So what I do, I exchange this bead in the 1's place for 10 beads in the 10's place, because 10 beads on this row is worth 1 bead up on this row. And now I can proceed. I can take 2 from here and add 1 up here, but I'm not going to add it to the 10's, but I'm not going to add it to the 1's place, I'm going to add it to the 10th's place. So I take 2 out from here, add 1, 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 take 2 out from here, add 1. There I go. I have my new midpoint value of 1.5. So my new guess for the square root of 2, my winner right now is 1.5. We'll record the current mid down here. So my current guess for the square root of 2 is 1.5. I'm pretty sure from experience that's not the answer, but we're going to check by taking now the square of this number. So I've got my midpoint. I finished with step 1. Step 2, I need to take my midpoint and square it. So again, I'm going to place my 1.5 down here in memory. 1.12345. There we go. Now I'm going to take this number and I am going to multiply it by 1.5. Let's work our way down here from the ones place down to the tenths place. So for the ones place, it's actually pretty easy. I'm multiplying by 1, meaning I take this thing and I simply leave it alone, right? I have a 1.5. Hooray, good for me. Now we're going to take this piece. Basically, what each one of these beads represents is adding this number to itself, but shifted down one row. Let me show you what this means. When I take 1 away from here, I get to take 1 on this side, and 1, 2, 3, 4, 5 on this row, right? I have now added 1.5, but it's all shifted down one row because this was shifted down a row. Well, now I do the same thing here. I take 1 off of here, and then I take 1.12345, move those over here. Take 1 off of here, and I'm going to get a 1 from here. Oh, I don't have any more on this row, so I'm going to trade in these 10 beads for 1 bead up here to get 1, 2, 3, 4, 5. There we go. Now I'll repeat that here. I take this piece here, meaning I get myself a 1 up here, and a 1, 2, 3, 4, 5 from this row. Let's see, I need to trade in these beads for 1 up here, but I also need to trade these beads for 1 up here, so I'll get 1 from there, 1 from there, hooray. I have 1 more to go, meaning I need to add a 1.12345 from there. So I end up with 1.5 squared gives me a 2.25. 2.25 is greater than 2. Right? 2.25 greater than 2, meaning I am too high. This mid value is too high. So we're going to take that 1.5, that mid value, we're going to record that over here under the wrong spot. But doing so well. So we're going to take that 1.5, we're going to record that as our new high value, right? So I've updated my high value. I don't update my low value because I got a value that's too high, not a value that's too low. Now we repeat. Let's clear our memory. There we go. And now we're going to take our low and high, add them together, and divide by 2. So we're going to take 1 plus 1.5. So we're going to take 1 plus 1.5. Here is a 1, and here is a 0.12345. Goes over that way. Okay. So we need to divide this 2.5 into 2. So I'm going to put this number, a copy of it down here, 1, 2, 3, 4, 5, into working memory down here. Okay, so let's start at the top, work our way down. I have 2 of these in the ones place, so I'm going to move 1 over. Here I've got 2, move over 1 in the tenths place, 2 from the 10th place, 1 back into the 10th place. Here I've got just 1 hanging out, so I need to have 10 of these here. Again, we're going to take 2 now from the hundredths place. I'm going to move 1 over in the hundredths place, 2 from the hundredths, 1 for the hundredths, 2 for the hundredths, 1 for the hundredths, 2 for the hundredths, 1 for the hundredths, 2 for the hundredths, 1 for the hundredths. I get a 1.25. 1.25 is now the current winner in midpoint, 1.25. So now I have changed my midpoint from 1.5 to 1.25. You might notice that we're getting an additional decimal place each time. That's the beauty of this bisection method, is that you're always going to be able to push it out to more and more decimal places as you go, because you're implicitly dividing by 2. That means you're going to end up with a 5 at the end somewhere. It's really cool. All right, let's now take this midpoint and square it. All right, let me copy this number over here, 1.2123445. Let's see, so I've now stored my 1.25 in working memory here. So now I'm going to take a 1.25, multiply it by 1. So it's going to be 1.212345. There we go. There, I've multiplied by 1. Now I need to multiply by a tenth, meaning I repeat that process, but I go down 1 row. So I go down a row here for a 1, 2, 1, 2, 3, 4, 5. So I've now taken my 1.25 and added to it 1.25, shifted down a row. Cool. Now let's do the same process here. I take a 1.25 2. 1, 2, 3, 4, 5. I better preemptively clear this register here to promote this one here, and then I clear this register here, promote this one here. Let's see, now we're going to do this in the hundredths place. So I move this over this way. I'm in the ones place, the tenths place, the hundredths place. I'm going to move out a 1.2, 1, 2, 3, 4, 5. All right, so I have to go down one layer lower each time I go. Let's see, let's take our next hundredths place. So we'll do a 1.25. No, let's see, we better promote this up here. Hundredths place. So on the hundredths place, I go 1.2, 1, 2, 3, 4, 5. Do the same thing here. I go over with a 1.25. Better clear that register. Better clear that register. There we go. I have one more left to go with a 1.2, 1, 2, 3, 4, 5. So this is my midpoint squared. I've taken 1.25 and squared it, and I've arrived at 1.5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1.5625. So I've taken this thing and squared it. The power squared, got 1.5625. Which is too low, right? I have to compare the midpoint squared to 2. I'm actually less than that. So my 1.25 must be lower than the square root of 2. So even though I don't have a decimal representation for square root of 2 yet, I do know that it needs to be somewhere between 1.25 and 1.5. I've made my update. Now it's time to repeat the algorithm. All right. So now I need to take the average of 1.25 and 1.5. Let's see. Let's start out with the more complicated looking one. Let's start out with a 1.2. 1, 2, 3, 4, 5. There we go. And I'm going to multiply that by 1.5. Let's keep track of that down here in working memory. 1, 2, 3, 4, 5. There we go. Okay. So my next goal is to add together 1.25 and 1.5. I have a copy of 1.25 up here, a copy of 1.5 down here. Let's start with the ones place. We'll take a 1 away from here, add a 1 up to here. We'll take a 0.5 from down here and add a 1, 2, 3, 4, 0.5 from down here. This one has no hundredths place, so the hundredths place stays the same. So here I've got my 2.1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So I've got 2.75. I now need to divide that number by 2. So let's make a copy of it down here. 2.7, 1, 2, 3, 4, 5. 2.75, 2.75. Okay, great. So we need to divide this number by 2. So for every 2 beads in the ones place, I carry over 1 bead in the ones place. For every 2 beads in the tenths place, I carry over 1 bead in the tenths place. 2 for 1, 2 for 1. Oh dear, I have an extra 1 over here. So I do not have 10 to carry over down here, so I think what I'll just do is carry over 1, 2, 3, 4, 5 in the hundredths place. Notice this is my tenths place down here. This is my hundredths place up here. Great. Now do the same thing in the hundredths place. I take 2, I get 1. I take another 2, I get 1. I take 1 over here. I need a 1, 2, 3, 4, 5. We are now down to the thousandths place. So I now have a 1.3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1.375 is the current guess for the square root of 2. That is the current winner. That is the closest value we have had so far. All right, our next goal is to square 1.375. So we'll start by making a copy of it, starting in the ones place. 1.3, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So there's 1.375. Then I need to make a copy starting in the tenths place. So 1.3, have to promote that. 7. 1, 2, 3, 4, 5. I need 2 more on this row, so I need to promote it here. Get me 2 more. That was 1.37. Now I have to go down into the tenths, hundredths, thousandths. I have to go down to the 10,000ths place to spit out the 1, 2, 3, 4, 5. There we go. Now let's repeat that process. I've got a 1.3, 1, 2, 3, 4, 5, 6, 7, and then a 5 here gets this one promoted, which gets this one promoted. All right, once more from the 10th place. I got a 1.3, 7, 1, 2, 3, 4, 5. All right, that's your 10th place. Now we start in the 100th place. For the 7, we're going to be 7, 5, 1 tenth, 100th place. I have 1.3, promote. 7, 1, 2, 3, 4, 5, promote. 6, 7, 1, 2, 3, 4, 5. So the 5 makes 7 more times. Go with tens, hundreds. Oh, no, this one. There we go. So I'm starting in 100th place this time. So I have 1.3, 1, 2, 3, 4, 5, 6, 7, 5, promote, promote. Same thing here. I do a 1. Nope, I'm starting in the, yeah, I'm starting with like 1.3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Good. Then I start in the 100th place. 1.123, 1, 2, 3, 4, 5, 6, 7, 5. Here, here. All right, once more from the 100th place. I got 1.3. 7 needs 2 more. 5, 1, 2, 3, 4, 5. All right, same thing again. 1.3, 1, 2, 3, 4, 5, 6, 7, 5. I never so nervous. I'm counting in my life. I think I've done it. 1.3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. All right, we had enough promotions last time that last one was much easier. Now we come to the starting in the 1, 2, 3, the thousandths place, the 3rd decimal place. So 1, 2, 3. Now I start down here. So with this one gone, 1, 2, 3, I'm going to add 1.3, promote 7. 1, 2, 3, 4, 5. Promote 7, 1, 2, 3, 4, 5. We are now down into the light blue row. We have not been there before. All right, starting on 1, 2, 3. Starting on the 1.3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Promote, promote. All right, we're starting up here now. So I think that's 1.3, 7, 1, 2, 3, 4, 5. 7 is look real and move fast. I think here, 1.3 is promoted. 7, 1, 2, 3, 4, 5, 6, 7, and a 5. Yes. Promoted. 1, promote. 1, 3, 1, 2, 3, 5. 7, 1, 2, 3, 4, 5. Okay. We end up with this thing squared coming out to less than 2, right? Really the only thing that matters, right? You know, it's good to get all these details right. But really the thing that matters is whether we move this second bead over. Because as soon as I move this second bead over, I know I'm getting bigger than 2, right? So this is going to be a 1, 2, 3, 4, 5, 6, 7, 8, and some change. The important thing is that it is less than 2, because I don't actually have to record the square value. I just have to record the midpoint as my new low value, 1.375. All right, let's try once more. Clear the memory. Let's try this one more time to get one last estimate here of what is the square root of 2 in a decimal representation. Okay, so I need to take 1.375 and add it to 1.5. So let's take 1.3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So I've got a 1.375. I'm going to add to that 1.5. So I did add to that 1.5. 1, 2, 3, 4, 5. Okay. So let's start by adding the 1. I'll add a 1 up here. And we'll add 0.5. 1, 2, 3, 4, 5. There we go. So I have a 2.875. I need to now divide that number in half. So we are going to take 2.875. I'll make a copy of that down here. 2.2468. 2467. 245. So I'm going to take now 2.87, divide it, 2.875, divide it in half. Start with the 1 place. 2 of these gives me 1. 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 2 of these give me 1. All right, even digits so far. Not so lucky here. 2 of these gives me 1. 2 of these gives me 1. 2 of these gives me 1. 1 of these gives me 1, 2, 3, 4, 5 on the next row. All right, so 2 of these gives me 1. 2 of these gives me one of these gives me 1, 2, 3, 4, 5 on the next row. So my next midpoint, my last guess for the square root of 2 is 1.4, 3, 1, 2, 3, 4, 5, 6, 7. And it should be a 5 at the end, right? 1, 2, 3, 4, 5. 1.4, 3, 7, 5. All right, so my next step is to square that lovely number, 1.4375. Let's make a copy of it down here. 1, 2, 3, 4, 5. Yes, I'll take away that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 3 and 3. 4 and 4. 1 and 1. Okay, 1.4375. We now need to square it to compare it with 2. So I will take the ones place and make a copy of 1.4375. I will now take this number and put it in the tens place. So 1.43, promote, 7, 1, 2, 3, 4, 5, promote 7, 5, 1, 2, 3, 4, 5. Very good. Now, let's take this one, repeat the same process starting in the tens place. 1 point, promote 4, 1, 2, 3, 1, 2, 3, 4, 5, 7, 5, 5. All right, now put it in the tens place again. 1.43, 7, and so that's 9, 5. All right, 1.4, promote 3, promote 7, promote 4, 5, and promote. Okay, I'm done with the tenths place. Now I'm going to start in the hundredths place. So I'm starting in the orange row now. 1.4, 3, 1, 2, 3, 4, 5, 6, 7, 5, 1, 2, 3, 4, 5. Good. Now again, starting in the orange. 1.4, 3, 4, 5, 6, 3, 4, 5, 6, 7, and 5. Go. All right. One more from the hundredths place. 1.4, 3, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5. All right, that is it for the orange row. Now we start in the yellow row. Yes, you notice I'm just catching up on my rows here. Let's see, now we're going to go to the yellow row. So 1.3, excuse me, hold on, 1.4. 3, 1, 2, 3, 7, 1, 2, 3, 4, 5, 6, 7, 5, 1, 2, 3, 4, 5. All right. Do that again, starting in the yellow row. 1.4, 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Promote, promote, promote. I guess I got 1.4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 1.4, 3, 7, 1, 2, 3, 4, 5. Go. All right, so now 1.1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 5. Promote. Again, I got 1, 1, 2, 3, 4, 3, 7, 5, 1, 2, 3, 4, 5. Great. All right, I'm ready. 1.4, 3, 7, 5. Great. All right, last one, we got 1.4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5. Oh, goodness. But really the thing that matters is whether we move this second bead over. Because as soon as I move this second bead over, I know I'm getting bigger than 2. Oh dear, I missed something very important. Promoted to 2. All right, this thing is too big. Right, so this square value is bigger than 2. So it is my new high value, 1.4375. I should have stopped as soon as I got that promotion there. So I know that the square root of 2 is going to be somewhere between 1.375 and 1.4375. So for our last step, we will take the average of these two numbers. First, let's add them together. I will get let's start with a 1.12345. Nope, just 4. 375. 1, 2, 3. 7 and a 1, 2, 3, 4, 5. Very good. Now we'll add these onto it. So we'll start at the top row with a 1. Go to the next row with a 1, 2, 3. This next part's interesting because I have a 7. 1, 2, 3, 4, 5, 6, 7. That gets promoted up to this row. And then I add 5 onto this row. 1, 2, 3, 4, 5, and promote that one. So I need to take this number and cut it in half. Let's start from the bottom, work our way up. So I will have 2, 2, and 1. So I can cut this down to a 2, and 1, 2, 3, 4, 5 on the next row. As we come to this row, I have a 2 here, so that's going to get cut in half here. I have a 1 here, so that's going to get me a 1, 2, 3, 4, 5 on that row. Up here, I've got 2, 4, 6, 8. I can cut that in half to be 4. And then up here, I've got a 1. So my next number is a 1.40625. That is my new guess for the square root of 2 to be 1.40625, which is actually pretty close to the actual value of square root of 2, 1.414. I've got it out to the second decimal place with just about an hour of working here on my abacus. So that's been a lot of fun. I enjoy working with this hardware and this algorithm. Looking forward to working with better hardware and better algorithms next time.